Would you feel confident living in a tower built in under 2 days? In China, builders recently demonstrated the speed of modern modular construction by assembling a 10-story residential building in just 28 hours and 45 minutes. A major factor behind this achievement is the Bcore slab system. Each panel consists of 2 steel sheets joined by a grid of welding tubes, with the gaps filled with insulation. This creates a lightweight, thermally efficient component that functions as both walls and floors. A standard panel measures 12 meters by 2 meters by 0.15 meters, or 39 feet by 6.5 feet by 6 inches. Compared to concrete slabs, Bcore panels are 10 times lighter, which means faster transport, easier handling, and reduced structural loads on the foundation. In modular construction, this makes them ideal. Entire buildings can be assembled like a giant Lego set, with precision-engineered parts locking seamlessly together. How would the construction industry change if nearly every component of a building could be delivered, stacked, and locked into place without traditional concrete curing times? With reduced weight, built-in insulation, and compatibility with prefabrication, Bcore slabs are more than just a panel. They represent a shift towards high-speed, resource-efficient urban development. Unlike traditional steel reinforcement bars, micro rebar consists of short, twisted steel fibers less than 1 millimeter thick. These fibers are blended directly into the concrete mix, creating reinforcement that is evenly distributed throughout the structure. The result is a composite material with performance that far surpasses conventional methods. Laboratories and field studies show that micro rebar increases the flexural strength of concrete by approximately 33%, while its fatigue resistance rises by as much as 300%. This means structures reinforced with micro rebar can endure heavier loads, vibrations, and repeated stresses without failure. The efficiency gains are equally impressive, replacing just 929 square meters or 10,000 square feet of traditional rebar. With micro rebar can save an entire day of work on a job site. This translates to reduced labor costs, faster project completion, and fewer logistical challenges compared to handling and tying bulky steel bars. In addition, micro rebar significantly reduces the likelihood of cracking, extending the lifespan of concrete elements. The fibers can be mixed directly at the concrete plant or added on-site during pouring, offering flexibility for contractors. The technology provides a cost-effective, durable, and scalable solution, positioning micro rebar as a key player in the future of reinforced concrete. While prices vary by supplier, typically it costs between $2,000 and $2,500 US per ton. One of the most overlooked weak points in a building is the balcony. Traditional construction often allows rebar to pass directly through insulation layers, creating cold bridges that cause heat loss, condensation, and mold growth. The Egcobox system solves this problem with thermal insulation blocks, designed specifically for balcony connections. Each unit ensures that structural reinforcement can pass through while maintaining a continuous insulation layer. The result is a balcony that feels like a natural extension of the interior, not a source of wasted energy. The system is fully customizable. Designers can use CAD or BIM data to order project-specific modules, and free software is available to guide the process. Insulation options include phenolic foam, mineral wool, and polystyrene, with thicknesses up to 12 centimeters or 4.7 inches. How much energy could cities save if every apartment balcony eliminated thermal bridges compared to standard methods? Egcobox offers higher comfort, lower heating costs, and healthier living environments. It is a small but crucial step in the broader movement towards sustainable urban housing. Would you choose an apartment knowing its balconies are energy efficient and mold resistant? SmartBark Siding is the world's first cladding material designed to replicate the look of natural tree bark while being made entirely from synthetic composites. The result is a product that provides architects and homeowners with strikingly realistic aesthetics, allowing a home to appear finished in rare or exotic wood textures without the environmental costs or legal complications of sourcing endangered species. One of the standard advantages is its practicality during installation. Panels are produced in large format sizes, reducing the number of individual pieces needed to complete a facade. For example, the Slim Pro Big Dan version measures 61 centimeters by 61 centimeters or 24 inches by 24 inches. Larger panels mean fewer seams, faster installation, and reduced labor costs for contractors. Durability is another key selling point. Unlike natural wood, SmartBark panels are insect-resistant and require minimal maintenance. This eliminates the need for costly chemical treatments, sanding, or frequent replacement, providing long-term savings. For property owners, each panel is also backed by an exclusive 25-year warranty, giving both builders and buyers confidence in its longevity. Prices generally range between $15 and $25 per square foot, positioning SmartBark as a premium but cost-effective alternative to traditional wood siding. For German company Harman, a building's facade is more than just an outer shell. It is the movement when a structure transforms into a symbol. Their specialty lies in creating custom curtain wall systems that blend engineering precision with architectural artistry. These facades are not simple installations, but the result of carefully orchestrated operations, where each panel is designed for both performance and beauty. The scale of their projects is impressive. For example, Harman has successfully clad a 53-story tower with 38,000 square meters or 409,000 square feet of panels. They have also completed entire medical complexes, such as a 19-story hospital, paired with a 16-story clinic. Beyond aesthetics, curtain walls protect buildings from wind, rain, and temperature fluctuations, while offering energy efficiency through modern glazing technologies. Compared to conventional exterior walls, Harman systems provide lighter weight, faster installation, and better insulation, all while elevating the visual identity of the project. It is this balance between function and expression that sets Harman apart. Their facades are designed not only to shield, but also to inspire. Would you rather live or work in a building that quietly serves its purpose, or one that makes people stop and admire its design? The world produces nearly 2 billion tons of sugarcane each year, and while the crop is mainly used for sugar and biofuel, it also generates a byproduct known as bagasse, the fibrous residue left after juice extraction. Traditionally, bagasse has been burned for fuel or discarded, but researchers at the University of East London have found a new purpose for it: construction. By combining bagasse with a mineral-based binder, the team developed sugarcrete, a versatile building material that can be poured into mods to form durable, low-cost blocks. Unlike traditional concrete, sugarcrete reaches its target strength 5 times faster, reducing curing time and accelerating construction schedules. Despite being lighter and cheaper, the blocks remain strong enough for load-bearing walls in residential and commercial buildings. What if the waste from sugar production could help solve the global housing crisis? Beyond performance, sugarcrete's value lies in sustainability. By reusing agricultural waste instead of relying on high-carbon cement production, it significantly lowers environmental impact. In regions where sugarcane is abundant, it offers a local, renewable, and affordable alternative to conventional masonry. Would you live in a home built from sugarcane if it meant strength, speed, and sustainability combined? Bathrooms and wet floors are notorious for water damage, often caused by small leaks behind tiles. The MapeGuard WP system provides a modern solution with its WP200 waterproofing membrane. This product is built from a polyethylene core sandwiched between non-woven polypropylene layers, forming a flexible yet durable sheet. At just 0.5 millimeters thick, or 0.02 inches, it offers protection without reducing usable space, especially valuable in compact bathrooms. Would you believe something thinner than a credit card could keep a bathroom waterproof for decades? MapeGuard sheets bond tightly to bare concrete, wrap smoothly around pipes, and can be tiled over immediately after installation. That means no waiting periods and no complicated layering, unlike traditional waterproofing systems that require multiple costs and curing time. By simplifying installation while improving performance, MapeGuard WP reduces labor costs and ensures long-time protection against leaks. For homeowners and contractors alike, it offers peace of mind that hidden water damage will not undermine expensive finishes. Would you choose a membrane that saves time and guarantees lasting waterproofing in your home? At ETH Zurich, researchers have developed a groundbreaking structural component known as the Smart Slab, a concrete ceiling panel designed using advanced 3D printing technology. Unlike traditional slabs, this innovation is twice as light while maintaining full structural performance. The prototype installation consists of 11 interlocking sections that together cover an area of 80 square meters or 861 square feet. Yet the entire assembly weighs only 15 metric tons, or about 16.5 US tons. In its thinnest areas, the slab measures just 20 millimeters or 0.8 inches, a feat impossible with conventional casting methods. Its efficiency comes from carefully designed internal voids, which not only reduce weight, but also provide ready-made channels for utilities such as electrical wiring, plumbing, and ventilation. The surface features an intricate decorative pattern that is more than visual. It has been engineered to enhance acoustic performance by reducing echo and improving sound quality in interior spaces. The Swiss innovation demonstrates how digital fabrication can save raw materials, reduce weight, and expand architectural possibilities. While Smart Slab is still in the research stage, projected costs are expected to be competitive once scaled, offering an environmentally efficient alternative to conventional reinforced concrete slabs. Windows and doors are critical to both the function and style of a building, and the Schuko Perfect system is designed to adapt seamlessly to almost any architectural need. Whether the project calls for sliding doors, panoramic windows, or balcony access systems, Perfect delivers consistent quality. It works equally well in new construction and renovations, and is widely used across residential, commercial, and industrial buildings. How valuable is it to have one system that can handle every opening in a project? Contractors benefit from sourcing everything through a single supplier, simplifying logistics. Extras like insect screens and shutters can be ordered through the same channel, ensuring compatibility. Installation is also streamlined. Some components can be fitted in as little as 10 minutes. Compared with juggling multiple suppliers and systems, Schuko Perfect provides a unified solution that saves time, reduces error, and guarantees a consistent finish. For architects, it means freedom to design without worrying about technical constraints. For homeowners, it means a reliable system that fits their lifestyle. Would you upgrade to a system that turns doors and windows into a perfect fit for every project? High-cone panels represent one of the most advanced cladding systems in modern construction, combining natural stone veneers with an aluminum honeycomb core. The result is a material that is both lightweight and incredibly strong, opening new design possibilities for high-rise and large-scale buildings. Compared with traditional solid stone cladding, high-cone panels are up to 80% lighter, yet they are tested to be 60 times stronger. This exceptional strength-to-weight ratio makes them particularly suitable for use in hurricane-prone regions, where they have successfully passed rigorous performance tests. Their practicality also translates into significant cost savings. Because the panels are thin and lightweight, they can be installed without heavy lifting equipment or thick layers of mortar. This reduces labor demands and accelerates construction schedules. In addition, the system contributes to LEED certification, a sustainability standard that increases the markability and long-term value of buildings. High-cone panels are not only durable, but also versatile in design, allowing for the use of premium natural stones like marble and granite without the limitations of weight. Prices typically range between $50 and $100 per square meter, or $4.5 to $9.5 per square foot, making them a competitive choice for sustainable, high-performance architecture. Restoring tired, weathered concrete usually requires resurfacing or replacement, both which are costly and labor-intensive. The Like New Concrete restoration system provides a simple, affordable alternative designed for professionals and homeowners alike. The process is straightforward. First, clean the existing concrete surface, then mix the two-part Like New solution and spray it on with an ordinary garden sprayer. The product fills pores, conceals stains, and smooths minor cracks, leaving the surface looking fresh and uniform again. Performance is another highlight. The coating is dry to the touch in just 30 minutes, allowing foot traffic almost immediately, and it fully cures in 2 hours. This makes it practical even in high-traffic locations such as stadiums, sidewalks, and commercial plazas, where downtime must be minimal. Compared to resurfacing or replacement, which can cost $50 to $100 per square meter, or $5 to $10 per square foot, like new is significantly more affordable. The product itself averages under $10 per square meter, or about $1 per square foot, delivering professional results at a fraction of the price. If you could restore concrete in under 2 hours for 1/10 of the cost of replacement, would you ever choose the old method again? Gravel driveways and parking areas often suffer from shifting surfaces, ruts, and unevenness. The Core Drive 5035 HD system solves this with an innovative polymer grid that stabilizes gravel and distributes loads evenly. At only 3 centimeters or 1.2 inches thick, the grid reduces gravel consumption by up to 60%, saving both material and cost. Yet thin does not mean weak. Each square meter can withstand loads of up to 450 tons, or 990,000 pounds. Would you expect a grid barely thicker than your finger to handle the weight of a truck? The grid locks gravel in place, creating a stable surface that is safe and accessible. It is particularly beneficial for wheelchair users and pedestrians, who often struggle with loose gravel paths. Installation is straightforward and requires fewer materials compared to traditional base systems. By improving surface stability and lowering long-term maintenance costs, Core Drive provides a sustainable and user-friendly upgrade to gravel areas. It is a clear improvement over untreated gravel beds that require constant refilling and repairs. Would you choose a system that makes gravel paths as solid and smooth as paved roads without the cost of asphalt or concrete? If fiberglass bridges can last longer, weigh less, and resist corrosion, is there really a reason to keep building with steel and concrete? Bridges have traditionally been made from steel and concrete, but Fiberline is proving that fiberglass composites can outperform both. Their FRP bridges, made from fiber-reinforced polymers, are up to 60% lighter than steel bridges and 80% lighter than concrete ones. This weight reduction means easier transportation, faster installation, and lower foundation costs. A lighter bridge can often be installed using smaller cranes and less labor, reducing both time and expense compared to traditional methods. Despite being lightweight, FRP bridges are remarkably durable. They resist rust, corrosion, and seawater exposure, making them especially valuable for coastal regions. They also withstand temperatures ranging from 80 degrees Celsius to 176 degrees Fahrenheit, down to minus 40 degrees Celsius or minus 40 degrees Fahrenheit, ensuring reliable performance in extreme climates. Maintenance demands are minimal compared to steel, which requires painting or concrete, which can crack and spall over time. And when an FRP bridge reaches the end of its service life, it can be recycled, unlike most conventional materials. If a roofing system could seal itself the moment damage occurs, would you ever settle for a traditional membrane again? Roofing membranes are critical in protecting buildings, and Sarnafil AT-FSH represents a significant step forward in waterproofing technology. Instead of relying only on physical barriers, this membrane incorporates water-reactive polymers. When exposed to moisture, these polymers expand to seal small cracks and punctures automatically, preventing leaks before they become major problems. This makes it especially valuable for sensitive buildings, such as data centers, pharmaceutical facilities, museums, and archives, where even minor water intrusion could cause severe damage. Compared to conventional membranes, which often require regular inspections and patching, Sarnafil AT-FSH extends roof lifespan and reduces long-term maintenance costs. The product is also cradle-to-cradle certified, highlighting its commitment to environmental responsibility and sustainability in construction materials. While standard roofing membranes may cost $4 to $6 per square foot, or $40 to $65 per square meter, advanced systems like Sarnafil AT-FSH can be higher, but their durability and reduced maintenance needs often outweigh the upfront expense. Layout errors on construction sites can be costly, but the BIM printer robotic system is designed to eliminate them. Rolling across the job site, it automatically marks layouts directly onto the ground. Using CAD data, the system can run in fully automated mode and switch to semi-automatic operation, taking commands from a PC, tablet, or even a smartphone. For maximum precision, it integrates with top-tier robotic total stations from Leica, Topcon, and Trimble. Specialized software handles mission planning, ensuring that lines, markings, and dimensions are reproduced exactly as designed. Think about the time wasted when crews spend hours pulling tape measures, checking chalk lines, and correcting mistakes. What if a robot could do all of that with millimeter accuracy without fatigue or breaks? That's the advantage of BIM printer. It doesn't tire, doesn't need rest, and can work continuously through lunch or overnight. The result is faster site preparation, fewer errors, and seamless integration into the digital construction chain. In an industry where even small mistakes can mean huge expenses, BIM printer represents a new era of robotic precision. Would you trust a robot to mark out the foundation of your next building? Based in Turkey, the DORCE Prefabricated Building and Construction Industry Trade Incorporated has become a global leader in modular and prefabricated construction. The company is renowned for its ability to deliver projects that range from luxury residential housing to temporary shelters for disaster relief, all using highly versatile building modules. Each module is manufactured off-site and arrives fully equipped with essential systems, such as plumbing, electrical wiring, flooring, insulation, and ventilation. This dramatically reduces on-site labor requirements. Instead of months of complex installation work, construction teams can simply position and stack the modules into place, streamlining the process. The efficiency is striking. This method is estimated to be up to 50% faster than traditional construction techniques. Large-scale projects, such as multi-story hotels, hospitals, or office complexes, can be completed in just a matter of months, rather than years. DORCE also emphasizes durability and adaptability. Since its projects are deployed worldwide, the modules are engineered to endure extreme weather conditions, seismic activity, and heavy usage. They could be tailored for highly specific clients, including emergency response units, energy companies, mining operations, and even military bases. Prices vary depending on scale and customization, but prefabricated housing modules typically range between $30,000 and $60,000 per unit. This makes them a cost-effective option for governments and private investors seeking speed, resilience, and long-term value in construction. Construction sites often face a common problem. Heavy machinery, constant traffic, and unpredictable weather quickly turn the ground into a hazardous mess. That is where Enduramat, ground protection mats from Sonco, provide a smarter solution. Unlike plywood, which breaks under stress, or steel plates, which are heavy and prone to rust, Enduramat panels are engineered from high-strength polymers. Each mat weighs just 32 kilograms or 70 pounds, yet it can withstand loads of up to 80 tons or 160,000 pounds. This strength-to-weight ratio makes them easy to transport and deploy without heavy lifting equipment. The benefits extend beyond the job site. Enduramats are chemically resistant, meaning they can be moved from site to site without contamination risks. They are also fully recyclable, avoiding the landfill fate of worn-out plywood and steel alternatives. These mats work equally well indoors and outdoors, whether protecting warehouse floors or stabilizing muddy construction zones. By keeping soil intact and equipment moving, they reduce downtime and cleanup costs. Would you trust a lightweight polymer sheet to do the work of steel on a busy construction site, knowing it could carry 80 tons with ease? Would you consider living in a home built from reusable, mortar-free blocks if it meant faster construction and lower housing costs? Many parts of the world, particularly in regions like Kenya, where affordable housing is in high demand, innovative construction solutions can make a real difference. One such development is Twist Blocks, a modular concrete block system designed to speed up building while keeping costs low. Unlike traditional blocks, Twist Blocks require no mortar at all. They interlock with precision, allowing walls to be assembled up to 10 times faster than standard masonry. The absence of mortar not only saves material and labor costs, but also ensures a cleaner construction process with less waste. Sustainability is another strong advantage. Once a building has reached the end of its life cycle, approximately 80% of the blocks can be recovered and reused in new projects. This stands in stark contrast to conventional brick construction, where demolition usually results in rubble that cannot be recycled efficiently. Twist blocks are already being produced at 3 manufacturing facilities, and more than 65,000 units have been made to date, highlighting both the scalability and growing adoption of the system. The Bison Level Up system is redefining how outdoor decks are built. Traditionally, decks require digging, pouring, and leveling concrete footings, a process that is both labor-intensive and time-consuming. Bison eliminates that hassle with an adjustable pedestal support system that allows builders to create a level foundation directly on top of soil, gravel, paving, or even existing concrete. Each pedestal is remarkably strong, capable of holding up to 340 kilograms or 750 pounds. They resist frost, mold, and moisture, making them reliable in harsh climates. Heights can be adjusted from 7 centimeters or 2.75 inches up to 18 centimeters or 7 inches without the need for special tools. The system even compensates for slopes of up to 8%, ensuring stability or uneven terrain. The recommended minimum deck size is 2.4 meters by 2.4 meters, or 8 feet by 8 feet, though the system scales easily for larger projects. Compared to pouring concrete, this approach reduces installation time dramatically while avoiding messy excavation. At around $8 to $12 per pedestal, Bison Level Up offers both affordability and flexibility. Would you trust a pedestal system instead of concrete footings for your next deck project? When Alabama began widening the U.S. Highway 43, contractors needed a reliable system to handle bridge expansion. The solution came in the form of Mevalite aluminum formwork, a lightweight yet remarkably strong construction system. Each panel measures 1.8 meters by 0.9 meters, or 6 feet by 3 feet, and weighs just 39 kilograms or 86 pounds. Despite this light weight, it can support up to 6.5 tons per square meter, or 1,300 pounds per square foot. This strength-to-weight ratio allows crews to position panels quickly without heavy machinery, saving both time and labor. Would you expect something so light to withstand the same loads as heavy steel formwork? Mevalite has proven that lightweight systems can deliver durability equal to or greater than traditional solutions. For projects like highway bridges, where efficiency and safety are paramount, it provides an ideal balance. With fewer delays and faster assembly, contractors can focus on quality work instead of struggling with cumbersome materials. It is another example of how modern engineering tools are reshaping infrastructure construction. At ETH Zurich, researchers have created an autonomous excavator capable of building complex stone structures without human guidance. Mounted on a Menzai M545 truck platform, the system successfully constructed a 6-meter high or 20-foot high wall, stretching 65 meters or 213 feet in length entirely on its own. The machine's intelligence comes from advanced mapping and algorithmic design. It generates a 3D map of the construction site, then calculates the weight, size, and center of gravity of each stone. Using this data, it determines the perfect placement for every block. Could you imagine a machine laying out stone walls more accurately than skilled masons? This technology demonstrates how digital precision can merge with physical construction. The long-term vision is to apply autonomous excavators to remote or hazardous areas, such as disaster recovery zones or unstable terrains where human workers face risks. Compared to traditional excavation and masonry, which require extensive manpower, this robotic system reduces labor demands and ensures consistent quality. It is in an early but promising glimpse into how automation will transform construction sites of the future. Managing wastewater and sludge is a growing challenge for municipalities, industries, and mining operations. The ACE Tube system offers a practical solution through large, flexible geotextile containers designed for dewatering and filtration. The principle is straightforward. Contaminated water is pumped into the tube, and as it drains, solids and sludge are trapped inside. Engineers can select different geotextile structures depending on filtration needs, and can even add flocculants, chemical reagents that cause particles to clump together for more efficient separation. How much money could cities save if sludge management became as simple as pumping into a reusable fabric container? Ace Tube's design is built for durability. The material resists ultraviolet radiation, acids, and alkaline exposure, making it suitable even for harsh industrial and mining environments. Compared to mechanical filtration plants, Ace Tube is faster to deploy, requires less energy, and is far more affordable. By transforming complex wastewater treatment into a portable, scalable solution, Ace Tube opens possibilities for remote communities, construction sites, and emergency situations where permanent facilities are not available. Alfred Miller Contracting has established itself as a leader in manufacturing precast reinforced concrete pile caps and related structural elements that are vital in modern infrastructure projects, particularly bridges and highway systems. Unlike traditional on-site pouring, which can be slow and prone to inconsistencies, Alfred Miller takes a different approach. Every pile cap is designed, cast, and cured in-house under controlled conditions before being delivered directly to the job site. This manufacturing method brings several advantages. By the time the components arrive, they are ready for immediate installation, eliminating many of the delays and uncertainties associated with fieldwork. In fact, in certain situations, as few as 3 workers are enough to maneuver the precast elements into their final position. This not only reduces labor costs, but also speeds up overall project timelines, a crucial factor in large-scale infrastructure development, where delays can mean millions of dollars in losses. Another key benefit is precision engineering. Producing pile caps in a controlled environment ensures accurate dimensions, smoother finishes, and reliable quality, standards that are often difficult to achieve when concrete is poured and cured on site. The result is a system that combines efficiency, cost savings, and structural reliability, making the precast technology a trusted choice for contractors and engineers alike. In crowded cities, traditional piling methods often create noise, vibrations, and disruption. The Kid Drill Foundation system from Kaibag Engineers was designed to solve these problems. It uses pre-manufactured screw piles that can be drilled to depths of up to 40 meters or 131 feet with almost no vibration and minimal soil displacement. This makes them ideal for urban areas, soft soils, and zones with high groundwater levels. The piles are constructed from high-strength concrete, ensuring long service life. A unique advantage is their reusability. Unlike traditional driven piles, Kid Drill piles can be removed and used again in future projects. Each pile also features a hollow core, allowing integration of geothermal probes or other utility systems, turning the foundation into a multifunctional asset. Compared to conventional pile driving, which requires heavy machinery and creates noise pollution, Kid Drill offers a quieter, cleaner, and more sustainable alternative. This reduces disturbance for residents while cutting overall installation time. Although costs vary, foundation systems like Kid Drill typically range between $200 and $400 per linear meter, or $60 to $120 per foot. Would you feel more comfortable living above foundations installed silently and sustainably, or with the noise of traditional pile driving? Installing tile on patios, porches, or rooftop decks has traditionally been a slow process involving mortar, grout, and hours of labor. The Embrico tile deck system changes this with an innovative rail and slot design that allows porcelain tiles to be mounted quickly and securely. The speed of installation is remarkable. 3 tiles with their rails can be set on a standard wooden deck frame in just 90 seconds, compared to traditional tiling, which may take hours for the same area. This system can cut installation time by more than half. Another advantage is versatility. The wide range of available tiles includes options capable of handling slopes up to 35 degrees, making the system suitable even for challenging applications, such as tiled roofs. Each tile is made from porcelain stoneware, giving it excellent resistance to mold, chemicals, frost, and staining, issues that often plague natural stone or ceramic alternatives. If you could finish a patio or even a roof in hours instead of days, how much faster would your construction projects move? The Perry Skyflex system is an advanced modular formwork solution designed for safe, fast, and efficient concrete slab construction. One of its most notable features is its roller lock technology, which uses gravity to automatically position beams and lock them securely into place. This eliminates the need for repeated manual adjustments and speeds up assembly significantly. Each lightweight aluminum component weighs less than 22 kilograms or 48.5 pounds, making them easy for a two-person crew to handle without a crane. Integrated polymer inserts are built to accept nailing directly, allowing decking to be secured quickly without extra preparation. A key safety innovation is the ground-level assembly tool. All work can be done from below without ladders, reducing fall risks and allowing two workers to set up large spans faster than traditional scaffold-based systems. Once assembled, the structure is sturdy enough to handle complex slab geometries for residential, commercial, and industrial projects. Durability is built in. The gravity locking reduces wear on connections, and the lightweight design minimizes transport costs while maintaining high load capacity. This combination of features means contractors can complete slab work faster, with fewer crew members, and with improved site safety. What was your favorite construction technology? For more content like this, click on the video on the screen.